So in my effort to make the study guide harder than the test, on your test, there will only be 10 of these questions. Here, there are 16. And also on here, these choices can be used more than once. On your test, they're each going to only be used once and exactly match up. So there will be 10 questions, 10 answers, and they'll all exactly match up. So you'll be able to use process of elimination for them. I just like to make this harder than the test. So the test will seem easier by comparison. So for this one, we're going to replace tangent with sine over cosine. And then the cosines are going to cancel and we get negative sine, which is sine of negative x. The odd ones go negative, the even ones stay positive. So since sine is odd, sine of negative x will equal negative sine of x. So that one is B. All right, for this one, I would write the Pythagorean identities off to the side. Sine squared plus cosine squared equals 1. And then you can either memorize the other two, or I'll just get them by dividing through this one. Like I'm going to divide each of these terms by sine squared. And then I'm going to divide each of these by cosine squared. And it's good to have those written off to the side, because then when you get to something like this, that helps you. So secant squared minus 1, if you subtract the 1 over, that's going to equal tangent squared. So that one is BF. Right here, we're going to replace secant with 1 over cosine, and we're going to replace cosine with 1 over sine. When you divide by a fraction, you multiply by the reciprocal. So I'm just going to flip this over. It'll be sine over 1. And so that equals sine over cosine, which is tangent. So that one is E. Right here, when you have something squared, you need to write it twice. So since it's already written here once, I'm just going to kind of scribble out the squared and write it again. And then it's first, outside, inside, last. So the first, sine times sine is sine squared. The outsides will give you minus sine cosine. The insides will give you minus sine cosine. So we have subtracted 2 sine cosine. And then the last will be cosine squared, and the negatives will cancel. So plus cosine squared. Sine squared plus cosine squared gives you 1. So these two that I've circled, if you add this together, you get 1. So it's 1 minus 2 sine cosine. So that one is L. Here we're going to replace cotangent with cosine over sine. And then the sine of x is going to cancel. We get cosine. So that one is C. Here we're going to distribute sine times cosecant. Those are reciprocals. So when you multiply them, you're just going to get 1. You can rewrite cosecant as 1 over sine if you want to show that the sines cancel. But either way, when you multiply those together, because they're reciprocals, you're just going to get 1 minus, and then sine times sine is sine squared. And 1 minus sine squared is going to give you cosine squared. So that one is D. Right here, sine squared plus cosine squared equals 1. So those together are 1. And then 1 plus tangent squared gives you secant squared. So that one is J. Here I'm going to replace cosecant with 1 over sine. I'm going to replace secant with 1 over cosine. And I'm going to replace cotangent with cosine over sine. So again, when you divide by a fraction, you're going to multiply by the reciprocal. So we're going to have this first part, 1 over, I'm going to run out of room here, sine of x cosine x times the reciprocal. I'm going to flip that over. So the sines are going to cancel. Cosine times cosine would be cosine squared, but it's 1 over cosine squared. And your reciprocal of cosine is secant. So that's going to be secant squared. So J for that. And see how both of these were J? That's not going to happen on your test. They're all going to match up exactly once. All right, 1 over tangent squared. I'm going to rewrite that as cotangent squared. Oh, and cotangent and tangent are reciprocals. So when they multiply, they're going to equal 1. I guess you could rewrite cotangent as 1 over tangent, and then the tangents would cancel. But when you multiply reciprocals like that, they're going to end up just being 1. And then cotangent squared plus 1 gives you cosecant squared. So that one is cosecant squared. So that is G. Right here, this one is a trinomial. It's exactly like if you had 4x squared plus x minus 3, we're going to split that. So this is going to split 4 tangent and then tangent, and then 3 would be 3 and 1. We want a positive 1 tangent in the middle. So I would want plus 4 minus 3. And so that one is going to be m. But again, like you're going to use the choices to help you. So when you see something like that and you know it's going to be factored, you can look through the choices and go, oh, this one looks factored and it has tangent and a 4 in it. You know, you're going to be able to link them up like that. Right here, I'm going to replace cotangent with cosine over sine. Secant is 1 over cosine. And then cosecant is 1 over sine, just barely fit that in there. So these cosines are going to cancel. And then these sines are going to cancel. So you have 1 over 1, which is 1. So that one is A. All right, here we're going to have tangent plus cosine. Cosine is an even one, so that's going to turn positive. Tangent is odd, so that's going to go negative. And then tangent minus tangent cancels. You just end up with cosine. So that one is C. Here, I'm going to rewrite cotangent as cosine over sine and rewrite tangent as sine over cosine. Now, to add this together, you need a common denominator, which is going to be sine cosine. So this one needs to get multiplied by cosine, and this one needs to be multiplied by sine. So when you put that together, this will be cosine squared plus, and then sine squared over the common denominator, which is cosine times sine, or sine times cosine. It really doesn't matter what order you put that in. But the numerator, sine squared plus cosine squared is 1. And then when you reciprocate these, 1 over cosine would be secant, 1 over sine would be cosecant. So secant, cosecant is K. When I kind of wrote over top of 14, it will. Cotangent, I'm going to replace with cosine over sine. Cosine, I'm going to leave that cosine, but I am going to write it over 1 because sometimes that helps to see what's going to cancel. And then cosecant is 1 over sine. So let's see. Nothing cancels there because you have to have something in the numerator and the denominator to cancel out, but we're going to have cosine squared over sine squared. Cosine over sine is cotangent. It's just that it's squared. So cotangent squared. So that one is N. Here, just like in number 13, we're going to need a common denominator, which is going to be cosine times 1 minus sine. So unfortunately, this one needs 1 minus sine. And this one needs cosine. So I'm going to distribute this sine into this parentheses. So that would be sine minus sine squared. And then minus cosine times cosine would be cosine squared. And then it's over the common denominator. So sine squared plus cosine squared is 1. It's just that they're both negative. So we're going to be subtracting 1. So this will be sine of x minus 1. Again, these two together would be 1. It's just we're subtracting it. And then we have sine minus 1 and 1 minus sine. Those are going to cancel, but we're going to need to multiply by a negative to make that happen because they were backwards from each other. So just algebraically, in order to cancel those out, when it's a reversal, you just have to multiply by a negative. 1 over cosine is secant. It's just that it's negative. So that is negative secant. So that one is H. I think that's probably the hardest one on here. Again, on your test, they're all going to link up. So, you can save the toughest ones for last, and you only have a couple choices left, and you can use, process of elimination to narrow it down. All right, when you see the 90 minus, that's a co-function. You just add or remove a co. So since this is cotangent, I'm going to take away the co, and it's just tangent. So that one is E.